Okay, next question. Figure 4 shows a plan view of a sheep enclosure. The enclosure, blah, 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 as shown consists of a rectangle, BCD, an equilateral triangle, and a sector FEA. They lie in a straight line with FE is equal to X, and X is between 10 and 25. Find in meters squared the exact area of sector FEA. So area of sector FEA is what we're trying to find out, giving your answer in terms of X in its simplest form. So it's going to be half r squared theta, which is equal to half x squared times, we know this is pi over 3. The whole thing is pi. So it's going to be pi minus pi over 3, because we want to find this, which is pi minus pi over 3, which is equal to half times x squared times 2 pi over 3, which means I get a third x squared pi. I said pi x squared, and I prefer it that way around, a third pi x squared. Okay, B. Given that BC is equal to y and y is greater than 0, the area of the enclosure is equal to 1000 meters squared. Area of enclosure is 1000, but what we do know is this is going to be 2xy. This is going to be, if this is x and this is x, then this is half x squared sine pi over 3, and this is already a third pi x squared from part A. So we know the area is equal to 2xy plus half x times x, which is x squared, and sine pi over 3 plus a third pi x squared. We know sine pi over 3 is root 3 over 2. So what I end up getting is A is equal to 2xy plus root 3 over 4x squared plus a third pi x squared. So that means if I combine 1 and 2, then 1 and 2 imply that 2xy plus root 3 over 4x squared plus a third pi x squared is equal to 1000. Okay, so I want to make y the subject of the formula. So 2xy is equal to 1000 minus root 3 over 4x squared minus a third pi x squared. If I divide by 2x, I get y is equal to 1000 over 2x minus root 3. When you divide the bottom by 2, I get double it. So root 3 over 8x, because when you divide by x, we're using a factor of x, minus a 6th pi x. Okay, so we need to combine these two. So I need to times 8 and 6. The lowest common multiple is 24. So I need to times this one by 3. And I need to times this one by 4. Okay, now if I look at the first term, I get 500 over x, which looks good because this looks like the first term of my other one. I get minus 3 root 3 over 8x. No, not 8, because I need to multiply the bottom by 3 as well. So I get 8 over 24. The whole point was I was getting a common denominator. Minus 4 over 24 pi x. Now we're combining these together. So y is equal to 500 over x. The common thing is x over 24, which is what we got. So inside the bracket, I get 3 root 3. Because I've got the minus at the front, then it was the plus. And I've got 4 pi in the next one, which is what I wanted. So if I rewrite it as 500 over x minus x over 24, 4 pi plus 3 root 3. Okay, C, hence show that perimeter P of the, I've just shown that, sorry, that's B. No. Hence show the perimeter is equal to that. Okay, so I haven't shown. So perimeter is equal to, let's use a different color, let's get green now. So this is 2x plus y plus y plus x plus the arc length. Arc length is r theta, so it's x times 2 pi over 3. So 2 pi over 3 times x. Okay, so that means I've got y plus y, so it's 2y. 2y plus how many lots of x? 1, 2, 3. 3x plus 2 pi over 3x. Okay, we know what y is equal to, so we can replace it. So p is equal to 2 times 500 over x minus x over 24 times, let's use a square bracket, 4 pi plus 3 root 3 plus 3x plus 2 pi x over 3. So if I multiply out the 2, I get 1000 over x, which looks good because it's the first term. 1000 over x minus x over 12, 4 pi plus 3 root 3 plus 3x plus 2 pi x over 3. I need to write here. I need to write everything over 12. So this is at the moment over 1. So if I write it over 12, I times by 12 here, I times by 12, I times by 4 to get 12 at the bottom, times by 4 there. So I end up getting P is equal to 1000 over x minus x over 12 times 4 pi plus 3 root 3 plus 36x over 12 minus 8 pi x over 12. So the x over 12 is common. So if I do that, it's P is equal to 1000 over x plus, let's make it positive here, x over 12. Then the only one that's positive is the middle, this term, is this one. So there's a 36. So I've got 36 here. 36, just mistake here, there's a plus there. So minus, from this term, I'm going to get minus 4 pi minus 3 root 3 because of the fact there's a minus in the beginning. And then from the last term, I'm getting plus 8 pi. So P is equal to 1000 over x minus x over 12, 36, minus 4 pi plus 8 pi gives me plus 4 pi minus 3 root 3, which is what I wanted. Okay, part D. Use calculus to find the minimum value of P. So this is the same thing as 1000 x to the minus 1 plus x over 12 times 4 pi plus 36 minus 3 root 3. So when I differentiate P, with respect to x, I am getting minus 1000 x to the minus 1 plus 1 over 12 times 4 pi plus 36 minus 3 root 3. So dp dx is equal to 0 at minimum, which implies minus 1000 over x plus 1 over 12 4 pi plus 36 minus 3 root 3 is equal to 0. When I differentiated it, I should have got a minus 2 there. So over x squared. Okay, so make sure you differentiate right, or else you're going to make a mistake everywhere. So that means I've got 1 over 12 4 pi plus 36 minus 3 root 3 is equal to 1000 over x squared. So if I change it over, then x squared will be equal to 1000 over 1 over 12 times 4 pi plus 36 minus 3 root 3, which means x will be square root of 1000 over 1 over 12 times 4 pi plus 36 minus 3 root 3, which gives me a value of 16.633928. So a value for x, which means p will be equal to 1000 over 16.6339 blah 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 plus 16.6339 blah 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 over 12 times 4 pi plus 36 minus 3 root 3, which gives a value of 120.2361 in my calculator, which means if I need to find it in the nearest meter, I get 120 meters. Justify your answer. To justify, I need to find the second derivative, so I'll have to go back here. So this was C. So I'll go back to E. Then I need to differentiate dp in terms of x again. So when I do that, I get 2000 x to the minus 3. Because I'm differentiating this, if I substitute x is equal to 16.6339 blah blah blah, then I get 2000 times 16.6339 blah 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 to the minus 3, which gives me a value of 0.43 blah blah blah, which is greater than 0. Therefore x is equal to 16.6339 is when minimum occurs. Therefore P is equal to 120 meters is min value of P. So that's that question done. It's quite long. Okay, next question. The diagram shows the part of the curve with equation y is equal to 5 minus a half x squared, for which y is greater than 0. The point Pxy lies on the curve and O is the origin. Show that AP squared is equal to quarter x to the power 4 minus 4x squared plus 25. Okay, so what I do know is the point, which is equal to xy, is the same thing as x 5 minus a half x squared. Okay, so that means this, if I draw a line, if I want to work out O to P, then using Pythagoras, I know this is x and this is 5 minus half x squared. Then OP squared is equal to x squared plus 5 minus a half x squared, which means I've got OP squared is equal to x squared plus 25 minus 5 over 2 doubled, which gives me 5x squared plus a quarter x squared. which means OP squared is equal to, sorry, x to the power 4. I missed a squared there, that's why I made a mistake. So minus a half x squared times minus a half x squared will be quarter x to the power 4. Okay, so that means x squared minus 5x squared will be negative 5x squared, so negative 4x squared. So I end up being 25 minus 4x squared plus a quarter x to the power 4, which can be rewritten as OP squared is equal to quarter x to the power 4 minus 4x squared plus 25, which is what I wanted. Taking f of x is equal to a quarter x to the power 4 minus 4x squared plus 25, find the values of x for which f dash of x is equal to 0. So the first thing I need to do is work f dash of x out, which is differentiate f of x. So b is f dash of x is equal to x cubed minus 8x. So if f dash of x is equal to 0, it implies x cubed minus 8 is equal to 0, minus 8x is equal to 0, which implies x times x squared minus 8 is equal to 0, which implies x equals 0, or x squared minus 8 equals 0, which implies x equals 0, or x equals square root of 8, or x equals negative square root of 8. Okay, if you want to simplify even more, you can rewrite that as x equals 0, x equals 2 root 2, or x equals negative 2 root 2. Okay, so it says next, hence or otherwise find the minimum distance from O to the curve, showing that your answer is a minimum. Okay, if I were to find out which one is the minimum, I need to work out the second derivative. So f double dash of x, which is equal to 3x squared minus 8. So f double dash of 0 is equal to 3 times 0 squared minus 8, which is minus 8, which is less than 0. Therefore, x equals 0 is maximum. And we're trying to find the minimum is max distance. Okay. F double dash of 2 root 2 will be equal to 3 times 2 root 2 squared, take away 8, which is 24, take away 8, which is 16, which is greater than 0. So max occurs, min occurs. So if it's greater than 0, minimum occurs. So minimum occurs at x equals 2 root 2. F double dash of negative 2 root 2 is equal to 3 times negative 2 root 2 squared, take away 8, which is still 16, which is greater than 0. Therefore, minimum also occurs at x equals negative 2 root 2. Okay, so if I want to find out the minimum distance, then I need to substitute minimum distance squared is equal to OP squared, which is equal to a quarter times either plus or minus 2 root 2, because both of them gives you minimum, to the power of 4, minus 4 times plus or minus 2 root 2 squared, plus 25. Which means OP squared, which is the minimum distance, is equal to a quarter times 64 minus 4 times 8 plus 25, which is equal to 16 minus 32 plus 25, which is equal to 9. OP will be equal to square root of 9, which is equal to 3. Therefore, minimum distance is 3 when x equals plus or minus 2 root. Okay, cylindrical biscuit tin has a close-fitting lid which overlaps the tin by 1 centimeter as shown. The radii of the tin and the lid are both x. And the tin and the lid are made from thin sheet of metal of area 80 pi squared. Okay, and so area 80 pi centimeter squared, and there is no wastage. The volume of the tin is V, show that V is equal to blah blah blah. So area is equal to 80 pi. But area is also equal to the area of all these things together. So it's going to be the area of this circular part, which is equal to pi x squared. But then we have another one at the bottom. So plus pi x squared. Plus this part of the lid, which is equal to x times, sorry, let me just rub this out. So it's going to be 1 times the circumference of the circle, which is equal to 1 times 2 pi x, plus the curved part of the curved part of the cylinder, which is equal to 2 pi x times, let's call this, introduce a new one, which is h, 2 pi x h, which means we've got, if we put these together, I've got, let's call this 1 and call this 2. 1 and 2 imply that 2 pi x squared plus 2 pi x plus 2 pi xh is equal to 80 pi, which means 2 pi xh is equal to 80 pi minus 2 pi x squared minus 2 pi x, which means h is equal to 80 pi minus 2 pi x squared minus 2 pi x all over 2 pi x, which means h is equal to 80 pi over 2 pi gives you 40 over x. So 40 over x minus 1. Okay, that's h. Now the volume of the tin is just the volume of the tin. So volume of tin is equal to pi x squared h, which is equal to pi x squared times 40 over x minus 1, which is equal to, if I multiply out, the x cancels out, so all I'm left with is 40 pi x minus pi x cubed minus pi x squared. There's pi in common, so I can take the pi out. So I end up getting 40x minus x cubed minus x squared, which is what I wanted. So this is part A. Use differentiation to find the positive value of x for which v is stationary. So B, that means I need to differentiate v with respect to x. So dv dx will be equal to pi times 40 minus 3x squared minus 2x at min pi times 40 minus 3x squared minus 2x is equal to 0. Pi is just a constant, I can take it out. I can change all the signs, so I end up getting, it's the same thing as writing 3x squared plus 2x minus 40 equals 0. Okay, if I factorize this, I've got 3x in one, x in the other. So if I put minus 10 here and plus 4, then I get minus 40. And if I simplify the middle terms, I get minus 10x plus 12x, which is equal to 2x. Which means x is equal to 10 over 3, or x is equal to minus 4. And they've said that the positive value of x, since x is greater than 0, x must be equal to 10 over 3. Okay. See? Prove that the value of x gives the maximum value of v. So I need to do d squared v over dx squared, which is pi times minus 6x minus 2. And you just substitute this x value in, at x equals 10 over 3 is equal to pi times minus 6 times 10 over 3 minus 2, which is equal to, if I put that into my calculator and I work it out, I end up getting minus 22 pi, which is less than 0. Therefore, at x equals 10 over 3, we have maximum value of v. D, find the maximum value of v. So v is equal to pi times 40 times 10 over 3 minus 10 over 3 squared minus 10 over 3 cubed, which is equal to pi times 2300 over 27, which is equal to 23 which is equal to 2300 over 27 pi. It was measured in centimeters cubed, so centimeters cubed. Okay, E is determine the percentage of the sheet metal used in the lid when V is a maximum. So E, sheet, so percentage surface area of lid is equal to pi times x squared, which is a circular part, plus the curved part, which is equal to 2 pi x, which is equal to pi times 10 over 3 squared plus 2 pi times 10 over 3 at this maximum value, which is equal to 100 over 9 pi plus 20 pi over 3, which if you put it together gives you 160 over 9 pi. So percentage of, percentage of metal used will be equal to 160 over 9 pi divided by the total, which is 80 pi, which we were given, times by 100, which gives us 22.2222 blah 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 percentage, which is equal to 22.2 recurring steel of metals used in lid. And that would be it. Okay, so what does f dash mean? It's dy dx, so it's the same thing as dy dx, and it measures rate of change of y with respect to x. Okay, that's what you need to remember. What does f double dash of x measure? It measures d squared y over dx squared, so it's the second derivative. It's the rate of change of f dash of x. So it's how f dash of x is changing with respect to x, or the rate of change of the rate of change of y with respect to x. So it's twice. So rate of change of the rate of change of y with respect to x. What would dx dy be a measure of? It will be the rate of change, because it's dx dy, is rate of change of x with respect to y. So e.g., if we have x is equal to 2y cubed plus 3y squared minus 4y, then dx dy is the rate of change of x with respect to y will be 6y squared plus 6y minus 4. So it's really important to remember what it defines, each of these things.